want to use it or just use it? Really? Thank you very much.
It's working already. Yeah.
J'ai juste enlevé vos affaires parce qu'on les voit à la caméra en fait. On met sur l'autre côté. Et celui-là aussi. Tac, je vais les mettre. Ah, je vais tous les mettre à bas.
Good afternoon and welcome. My name is Marie Blanc and I'm leading the Westinghouse outage and maintenance services for Europe.
Good afternoon, everyone. My name is Arnaud Pellet, leading the major project organization for Westinghouse in Europe.
And we are here to share a little bit about the evolution of our welding and machining capabilities in Europe today. So if we start, we have been doing welding and machining for a long time and inspections, and that means gathering some experience, operating experience across the globe. And through that experience, we have concluded 4 key themes that we think are vital for operating successfully. If we start with innovation and technology, of course, innovative solutions are always interesting. We put a lot of attention to robust innovation and technology that continuously improve and continuously innovate, because that means that our tools and solutions can be very quickly put in deployment and adapted to the situation in question. Secondly, when it comes to qualified human resources, the skill sets are, of course, very, very important, but also the flexibility of the resources. Since we often end up supporting not just planned projects, but also emergent resolutions, the flexibility and the change with resources is very vital. Infrastructure helps us being able to make the quick design, the concept, prototyping, testing, qualification, going over to deployment. And that infrastructure is something that we are right now enhancing in Europe, and we'll get back to that here later. And it's also to help a quick deployment. And then lastly, integrated solutions. Integrated between the technology we use, between the welding, machining, and inspection solutions, integrated between different resource groups we have, but also integrated with the customer, where we see that the partnership with the customer for deployment of these type of efforts is the best way to succeed in delivery. So today we're going to share first just a little quick snap on some of the technologies that we base on. We're going to go over to some applications and field service projects, and we're going to finish up by presenting our change capabilities. So if we start with narrow group weld heads. So in pictures you can see a couple of interesting weld heads that have recently been used. And I would be interested if you can tell me a little bit more about them, Arnaud.
Thank you, Marie. So the narrow groove weld heads are typical in-house product. They have been fully designed and built by Westinghouse. This is a result of continuous improvement, integration of technology, and of course experience. More than 20 years of collaboration between engineers and technicians to build this equipment. This is also an equipment that is designed on a modular approach. It is really versatile and can be used for OD, outside diameter, inside diameter, but also for a large range of diameters and piping schedule.
So deploying these weld heads remotely has its challenges. So can you please tell us a little bit more about how do we ensure consistent and solid weld quality with these weld heads?
Sure. So let's talk about first about weld quality. Weld quality is achieved when you have comfortable margin as compared to the mechanical standard for NSSS design. And of course, with a low rate of defect, either for qualification or for site implementation. To do that, Westinghouse made the decision to go through systematic and robust qualification program because, as you know, welding is not black and white and there is a lot of gray area. So to do that, first of all, we decided to define the nominal mode, what type of welding process we will choose, what type of filler material, for example. Then we go to the limit testing phase with a lot of tests to push the limit of every parameters for the welding process, but also for the post-welding heat treatment, for example. Then we move to a qualification phase where we target to qualify a process within the limits that has been defined previously. We need also to identify and qualify the repair modes and to do what we call robustness testing, to test and to learn about the process through simulation of issues and degraded modes. And of course, all of this process, test and qualification are made in parallel with the NDE process to make sure that at the end of the day, the weld that has been done can be controlled with our NDE tools.
So then going to the NDE sides of things, in our recent experience, we have deployed advanced duty techniques for the inspections. So can you also clarify a little bit on the phased array duty and TOFT techniques compared to historical radiographic testing?
Yep. So the first advantage is obvious. If you are not implementing RT techniques, you remove all the risk associated to these RT techniques, radiographic radiation or gamma sources issues. You have also a lot more information due to the higher capability for detection. You can learn more about the weld, and this is very useful and easier for the inspection activities. The data management is also very useful since this is fully integrated to the system, so it's easy to share, easy to record, and to work with this data within different teams.
And then a quick note on another welding technique, so temper bead welding. Why would we use that?
Temper bead. So what is that? Temper bead is a TIG machine welding process which consists in applying 3 different layers of temper beads. When you are doing a repair in the field, it could be sometimes very difficult to implement pre-heat or post-welding heat treatment operation. Indeed, you are not working in the same environment as a shop. So when you have to repair complex shape or complex equipment, implementing pre-heat or post-welding heat treatment solution could be very difficult. So this solution can avoid this operation. Westinghouse implements this solution since 1999 in different countries such as US, United States, Belgium, Sweden, and UK, mainly on primary components such as the reactor vessel or pressurizer.
All right, so now we'll move over to some applications, field services projects, recent projects we have performed in Europe specifically.
So the first one is the most recent one. Here we are talking about the main steam repair at Flamanville 3. This is for us a first of a kind in the industry. We repair the main penetration weld through the RID with a dedicated robot. And to do that, we move with a lot of design. We move with 8 robots specifically designed for this application to do every step of the repair, the cutting, the chamfering, the welding, and all the control associated. And of course, you know, when you are repairing this weld penetration, first of all, you have to cut the weld to be able to introduce the robots into the pipe for the repair. We are very proud to have been able to develop, test, and qualify this process within a 12-month duration, compared to something that is usually done in 48 months. More than 300 people are still working on this project. It's still ongoing. We have team made with EDF and Westinghouse engineers coming from France, USA, Sweden, UK, Germany, and Spain and Belgium. Hopefully, we made it right at the first time with 0 defect. And from a safety standpoint, it was also a success without any day away case. So the project is still ongoing. The team are still working very hard to make this project successful until the end. We are currently closing the line, the main steam line, and starting to repair the feed water line. This is what you can see on the top picture, the picture on the top. The red line are the main steam, and the blue one are the feed water line. The robot that you can see on the bottom left is a cutting machine that has been installed to cut and to remove the first sleeve. Another project that Westinghouse did some years ago in 2016, it was at Gravelines, and this project was also first of a kind. It was the bottom-mounted instrumentation nozzle repair. Basically, on this reactor vessel, a defect has been identified on the penetration on the bottom on the reactor vessel, and the target and the goal of the project was to remove this penetration and to install a plug at the same place. It was also an industry first of a kind, and thanks to this operation, the EDF was able to pursue it and continue to operate the reactor. For this one, 20 robots were designed for every operation of the project. All the robots was operate remotely from a 20-meter height. We implement the entire operation during an outage, and we stuck to the original schedule with a total duration of 57 days. More than 150 people were involved on that project, coming from different countries, again, France, USA, and Sweden. Zero defect. We were proud to do that right at the first time again. And 0 DOA case. On the picture, you can see on the top the plug that has been installed on the bottom of the vessel during the welding phase. And on the bottom, this is a picture of the robot designed for the penetrant testing operation.
So now to a completely different type of intervention where we have deployed our welding, machining, and inspection capabilities. Wear of the thermal sleeves is a phenomenon that several operators across the world have experienced issues, some more aggressively than others. And earlier this year, one European operator, Sizewell B, had issues with this, discovered during the outage. And we were fortunate to be able to support them in resolving that issue. This included an assembling of teams from across the globe 5 days after the issue at site, and within 3 months completing manufacturing, training of operators, qualifications and tooling, finalization and intervention in 3 months' time. And the last example, which is also very different, but still in our welding and mechanic capabilities, is the weld overlay process, which can be used on different components and phenomena. So in this particular case, also a very recent example in Europe, was flow-induced corrosion and wall thinning of main steam piping. And we had a large number of people supporting the customer by handling this issue, and it included preparing of surfaces through sandblasting and in some cases even grinding due to the surface conditions, which was one of the biggest challenges in this project. And we deployed in parallel 6 robots to be able to clad this whole surface in a very short time frame. And we're talking about 300 square meters of cladding and several tons of weld wire that had to be used to be able to complete this project on time.
So let's talk about Westinghouse capabilities worldwide right now. Just quick comment on the picture that you can see on the screen. This is our recent workshop at Chaponnet, south of Lyon, that has been opened in January this year. And this is a place where we are doing all of our testing, development, qualification for the benefit of our customers. We are very proud of this tool, and our engineering and technician team really enjoy to work together in this new workshop.
So just a quick glance on the map. While we have locations across the globe with Westinghouse resources, there are a few key ones when it comes to the welding, machining and inspection services that are sort of our centers of excellence. We work very closely together with our American colleagues with significant experience, and they are marked over on the little map. And then our center in Europe for, or I would call it our hub, maybe we should call it, for inspection services is up in Sweden. And now we are having, in addition to our previous locations in France, augmenting our resources and footprints here in France.
So all of these organizations across the world are working together the same way, with the same principle. We have a long-term cooperation to share experience, to share resources also from one country to another, to make sure that there is a transfer of knowledge that is appropriate. Every entity is working with the principle of integrated and autonomous engineering to make sure that we have a full and total control of the chain and of the process that we are developing. Of course, the skill set of our people is very important, so we spend a lot of time on training to have a highly skilled and operational workforce. And we use modern workshop equipped with tooling and system dedicated to welding and machining solution. The picture is a steam generator that is prepared for a replacement operation. Our colleague from the US PCI have a large experience on this type of operation, more than 120 steam generators replaced all over the world. We are also working with the same operating rules. Proximity, it's really important to have people localized, close to, localized where the business is and close to the customers. Thanks to that, we are able to have enough customer intimacy, but also to have a good knowledge of the local regulatory requirement. Responsiveness is also very important. The welding teams and the solution needs to be developed, qualified as fast as we can in order to serve our local customers. And reliability is also a very important criteria with the use of robust, proven, and innovative technology that, as I said earlier, fully in-house product. Some figures about the operating capabilities. So 80 welding and machining engineers all over the world, more than 100 highly skilled welders. We have also the capabilities to mobilize more than 600 field service people dedicated or skilled with welding and machining activities. A total of 25,000 square meter floor space within 8 welding and machining workshops all over the world. This slide is dedicated to our new welding and mechanics solution organization. The idea here is to increase the European footprint, to have a full and total control of the chain and of the process that we are developing. And we use modern workshop equipped with tooling and system dedicated to welding and machining solution. More than 20 steam generators replaced all over the world. with local capabilities. This organization is based at Chaponnet in France, south of Lyon, in a new workshop dedicated to development, testing, qualification, and training. And of course, we will continue to work with our colleagues in the different countries, in the US, in Sweden, to work through the model that is clearly in the ADN of Westinghouse, the one Westinghouse model with the same principle that has been presented earlier.
So if we go back to the 4 tentacles we talked about in the beginning, with the innovation, with qualified resources, with the infrastructure, and with the integrated solution, we believe that with the expanded capabilities, both resources in France and in Europe, and footprints in Europe, we will be able to enhance those additionally. And we are very glad and proud to not just serve with these resources the operating fleet, but also be able to contribute to the expansion of new plants in one way or the other, and across Europe as well as in France. And we are out of time right now, and we can answer questions on the side if needed, and you're also welcome to the Westinghouse booth if you want to meet some of the people that have been involved in the recent projects at Flamanville 3 and in Gravelines, because they're here with us today. Thank you very much for your attention.
Thank you very much.